Hello everyone, my name is Adlan Sasanika and my student ID is 23151011057. So today, in this video, I'll be presenting my final exam project for web technology course titled with Smartpos Point of Sale System. So Smartpos is a point of sales application with complex features including automatic calculations, dynamic stock management, detailed activity logging, data visualization, and REST API support. So in this presentation, we'll be divided into three main parts. The first one is the database schema and ERD, and the second one is the complex feature and demonstration, and third is the code walkthrough focusing on business logic. Okay, so let's start for the first part is the database and ERD explanation. Okay, so here I'll be showing you my database with my table list. Okay, so let me start by explaining the database structure. So this system uses 7 main tables that are interconnected. So as you can see, the 7 tables are users, categories, product, transaction details, stock movement, sessions, product, password, migrations. For the users table, yeah. So here I only have 2 roles, admin and cashier. So this supports the multi-role authentication requirement. Users have one-to-many relationship with transactions and activity log. And next, we are going to the categories and products. Okay, so here, each product belongs to one category. So notice in the product table, we have initial stock column. So this is crucial. We don't manually update stock here. The current stock is calculated dynamically from this initial value plus stock movements. This is one of the complex logic requirements. So we also have purchase price and selling price to calculate profit margins and asset values. And then for the transactions, there's transactions and transaction details. The transaction one is they stores the header information like invoice number, subtotal, discount type, discount value, tax, and grand total. All these values are calculated automatically, not manually input. Notice we have discount type with percentage or nominal. I will show you in the demonstration. So this allows flexible discounting. The transaction details table, here, let me show you. Now, on this table, the table stores each item in the transaction. So this is a classic master detail pattern. One transaction can have many details item. Okay, now we move on to the another table, stock movement. So this is the most important table, stock movement. This is where we track every stock change. The type column has in or out. When we make a transaction, it automatically creates an out record. If we return items, it creates an in record. So let me show you an actual data. Okay, as you can see here, each movement records which product, which transaction type in or out quantity and description. So to get current stock, we calculate initial stock plus sum or in movements minus sum or out movements. So this is computed in real time, not stored. So this ensures data consistency and provides complete audit trail. Okay, next we move on to the other tables. We have activity logs. So in this table, records every actions in the system. Notice the changes column with JSON type. This stores specific change details. For example, if we change a product price from 75,000 to 80,000, it doesn't just log product updated, but the exact old and new values. This is the upgrade requirement from the assignment. Next, I wanted to show you the ERD. So here's the complete ERD showing our relationships. The key relationships supporting complex features are, the first one is product to stock movement for dynamic stock calculation. And then we have transactions to transaction details, master detail pattern. And then next one is transaction to stock movement, automatic stock updates. And then user to activity logs, audit trail. And All foreign key use cascade delay for data integrity. I think we have to move to the demonstration. So in this page, I already log in as a cashier. Um, Let me show you the login page first. Okay. Um, let us try. Okay, let me move this first. Let us try to log in as an admin. So I can show you the admin features first. Okay, so here we're already at the admin page. So here we're exactly in the dashboard. Notice we have several statistic cards showing today's transaction, this month's revenue, and total asset value. Below, we have three charts using Chart.js library, all pulling real data from database, not hard-coded. We have a line chart for 7-day revenue trend, a bar chart for top 5 products, and a pie chart for sales by category. Let me check the current stock before we do a transaction. Okay, so here we check the initial stock. Here in products, we can see all items with their current stock. Notice how mouse wireless currently has 50 units. Oh, it's not 50 now. Wait, it should be 50. Oh, I already tried to feature in the cashier one, so it's 43 right now. And the keyboard has 30 stock. So these numbers are calculated dynamically from the stock movement table, not stored directly. And here we can add if we wanted to sell a new product. And then we're moving to, oh no. Let's try adding um a new thing in the product. Let's try this one. We can upsell it like this, and the database will be automatically changed. See here. Then we look at the database. Here, coffee is automatically changed. Okay, so let's move on to the um at let's just change the another menu. So here we're at the laporan menu. We have the reports with the date filter. So I can select start date and end date. See here, but because it's just started today, so I can say that I cannot change it to the other date. But yeah, here we have all the reports. This is when I'm trying to use the feature in the cashier, and this is the transaction. Okay, so now we wanted to try the cashier feature. Okay, so let's just continue the continue the demonstration because there's something wrong with my Postman because I don't know what's the problem. So I will show you the API on the last part of the video. So here we have dashboard, product, transaction, and report. If we wanted to make a transaction, here's the record, and then here's the report, same as the admin one. And then here's the info of the product in case the customer wanted to ask about the price. And then here's the dashboard. And if we wanted to make a new transaction, we can just click here and we choose which one is it, if it's shared. And if we have a discount, we click the percentage and then how much is the discount. Let's say it's 70%. So here's the total prices that the customer should pay, and then we save the transaction. And if we want to make a receipt, we just click here, and then the receipts is already printed. Okay, so here's our recent transaction. We can see it on the dashboard. Here, the chart is changing, the chart is raising, and it's on the report also. Okay. So next, I think that's all for the cashier. That's nothing much of it, and we can move on to the code walkthrough. Actually, I have to explain the API, but I'm fixing the postman, so I think we just go into the code walkthrough. So here I have the code here. So I just want to do routing and the business logic implementation. I have the where should I go first? Okay, here. So here's the transaction controller, the store method. This is where all transaction calculations happen. So let me through step by step. Okay, so first we need the validation. We validate the items array. Each must have product ID and quantities. Also validate discount type and value. And then the second step is the critical one, the stock validation. We loop through each item and check current stock. Notice we call product current stock. This accessor calculates it from stock movements in real time. If any item has insufficient stock, we throw an exception and roll back the entire transaction. So this ensures we never oversell. And then we calculate the subtotal. So here is the discount. So if discount type is percentage, we calculate discount amount as subtotal times percentage by divided by 100. If nominal, we just use the discount value directly. So this flexible discount system is part of the complex logic requirement. Okay, for the tax. For the tax calculation, after subtracting discount from subtotal, we multiply by 0.11 for 11% FAT. This is current Indonesian tax rate. And then for the grand total, subtotal minus discount plus tax equals grand total. Simple math, but critical for accuracy. Oh, and then for the invoice, we generate unique invoice number. The format is IMV date sequence. We query today's transaction count and increment. And then after the transaction with all calculated values, then we save details and create stock movements. This is crucial. For each item, we create a stock movement record with type out. This is how stock decreases automatically. And finally, for the activity log, with the transaction details, everything is wrapped in a database transaction with try catch. So if anything fails, everything rolls back. Okay. And then here we're at the models of the product. So here I will be show you how current stock is calculated. This is in product model. The get current stock attribute the get current stock attribute is a Laravel accessor. It queries stock movement table, sums all in types, sums all out types, then returns initial stock plus in minus out. This runs every time we access product if more than current stock. So it's always accurate because it's computed from movement history, never stored. Um, and then We also get a set value attribute which multiplies current stock by purchase price. So this gives us the total value of inventory for this product. Okay, in here we're at the charts. So this is how we prepare data for charts. This is dashboard controllers. So for the 7-day revenue chart, we use Eloquent with DB row to group transaction by date and sum the grand total. So we select date and sum of grand total, filter last 7 days, group by date. This returns daily totals. Then we format it for chart.ts, creating arrays for labels and data points. So we look through 7 days, check if we have data for each day. If not, we put 0. This ensures the chart always shows 7 points even if some days have no sales. So for top products chart, we join transaction details with product table, some quantities, group by product, and limit to top 5. All raw queries using DB raw for aggregation. This is efficient database querying, not loading all records into memory. And then for the category cells, same pattern for category by chart, join through products to categories, some quantities, group by category name. All this prepared data is passed to the view, where chart.ts renders it into visual charts using JavaScript. And for all the detailed controllers and models and for the migration, I guess that's not enough space in this video. I already deployed it on my GitHub and I provide the link on the PDF. You can see it there. To summarize, Smartpos implements all required complex features like multi-role authentication, detailed activity logging, dynamic stock calculation, without manual input, automatic transaction calculations with discount, text, date filtered reports, interactive charts with real database data, and REST API with business logic validation. The system uses proper database relationships, Laravel Eloquent for queries, and follows MVC pattern with clear separation of concerns. So that's all for my explanation. Thank you for your attention.